The thermal infrared camera on board Venus Express has peered into the thick atmosphere and allowed scientists for the first time to map the wind speed in 3 dimensions. To achieve this, the thermal camera tracked clouds at 3 different levels in the atmosphere, including those just 50 kilometers above the surface, for long periods of time. This provides enough data to allow scientists to start piecing together a picture of the atmospheric phenomena. Data from the onboard spectrometers have shown that the amount of toxic sulfur dioxide varied considerably over just a few days. Sulfur dioxide is not thought to stay for very long, and so it must be being released into the Venusian atmosphere. Otherwise, it would disappear. But how this is occurring or what mechanism is releasing this gas is not known. It is likely to be released during volcanic eruptions, but there is as yet no evidence of this process taking place. Water vapor is present in the atmosphere of Venus, but in a very low quantity. Venus Express detected the way in which the atmosphere of the planet is being lost to space. This has provided vital clues as to what happened to the water on Venus. High in the atmosphere, water is broken down into its constituent parts, which are then stripped from the atmosphere by the solar wind, meaning that Venus is still losing water. Measuring the amount that the planet is losing from the atmosphere and calculating backwards over time indicates that Venus may once have had the same amount of water as the Earth does today. Venus Express data confirmed that the Venusian atmosphere generates its own lightning. This was an important discovery as electrical discharge breaks molecules into fragments, enabling chemical processes to take place that would not otherwise be possible. Lightning also occurs on Earth, Jupiter, and Saturn. However, on Venus, it is unique, as it is the only type known to be associated with clouds of sulfuric acid.
Since its launch, Venus Express has revealed new aspects of the planet and will continue to peer into and through the Venusian atmosphere to piece together answers to as yet unsolved questions. Are volcanic eruptions responsible for topping up the levels of sulfur dioxide in the atmosphere? Will Venus Express detect a volcano erupting? Venus seems to have been more Earth-like in the past and to have had large quantities of water. What happened to cause its climate to change so radically, and when? What will happen to the Venusian atmosphere in the future, and how will the climate evolve? Mars Express is the European Space Agency's first mission to Mars. Launched in 2003, Mars Express was designed to study the atmosphere and surface of Mars from orbit, using a suite of 7 instruments. These instruments study Mars in a wide range of wavelengths, including radio to probe beneath the surface, visible and infrared spectrometers to look at minerals and ices on the surface, and ultraviolet and infrared to find out in more detail what elements exist in the atmosphere. Mars Express also has a high-resolution stereo camera in the visible domain that has provided spectacular and detailed images of the surface of the red planet. This mission has been and is still a great success.
In 2004, Mars Express made a surprising detection of methane in the Martian atmosphere. This observation was later confirmed by ground-based telescopes. Further observations from Earth detected plumes of highly concentrated methane. In the atmosphere around Mars, methane is thought to be able to survive for just a few hundred years. The fact that we observe it now means that it must have been produced recently. The source of the methane is unclear. Could it have been produced by recent life or volcanic activity? Or was it produced a long time in the past, trapped in the ice and then released as the ice melts with the changing seasons? With the help of data from Mars Express, scientists have now found evidence that water existed on the surface of Mars for a sustained period of time and have started to unravel its history. The evidence came from the detection of 3 minerals that provide a record of water-related processes on Mars. Clay-like minerals, sulfates, and iron oxides. Clay-like minerals formed during exposure to large bodies of water. Once these seas and rivers were lost, water at times would burst out from beneath the surface of Mars and evaporate immediately, creating sulfates in the process. Over time, the remaining underground water became frozen, and gradually, iron oxides were formed on the surface without liquid water. Like Earth, Mars has polar ice caps, which for some time have been known to consist of a mixture of water ice and carbon dioxide ice. A radar on board Mars Express is actively probing the southern pole and has detected frozen water beneath the surface. This is the first time such an experiment has been carried out on any planet. Mars Express data are building maps of this subsurface ice. It is possible that water may exist below the surface in liquid form, but it could be too deep for the radar on board Mars Express to detect. Detailed Mars Express images have shown features on the Martian surface that, if seen on Earth, would have been formed by glaciers. The odd thing about these features on Mars, such as those seen at the base of Olympus Mons, is that they are observed at tropical latitudes, regions that in the past would have been too warm for glaciers to exist. It is thought that this could be the result of changes to the tilt of Mars' axis due to its temporal evolution. The tilt of the axis allowed Olympus Mons to be located at latitudes where glaciers did form.
Mars Express has provided fundamental discoveries which have greatly improved our understanding of Mars. However, new questions have also been raised as a result of the new data. To answer these questions, further exploration is required by Mars Express, as well as future generations of explorers. Very little is known about the internal structure of Mars, whether it has a solid or liquid core, if there is a convection zone as on Earth, and how thick the crust is. New data suggests that Mars has gone through some extreme changes in climate. Why this happened is not understood, and by studying this might help us to further understand the long-term changes in the Earth's climate. No evidence for life on Mars has yet been uncovered. If life did evolve on Mars, it may be that there are just a few places where it has survived. These could be underground. If life did not start on Mars, it would suggest that life is not very easy to start, therefore making life on Earth more remarkable and reducing the chances of finding life elsewhere in the universe. Understanding the extreme environment of Venus could play a key role in understanding the Earth. Venus Express will continue to study this planet, and scientists are looking at the possibility of changing the spacecraft's orbit for a better view. The addition of the Japan Aerospace Exploration Agency, or JAXA's, mission to Venus will provide a complementary view. And for the first time, 2 spacecraft will orbit this mysterious planet. Looking further into the future, Mars will continue to be explored in even greater detail with 2 new missions in the ExoMars program. One mission consists of an orbiter and an entry, descent and landing demonstrator, and the other will be comprised of the first European rover to land on the Red Planet. Ultimately, scientists want to bring a sample of Mars back to Earth to study in detail in laboratories. The exploration of Earth's siblings, Venus and Mars, continues to result in important discoveries. Venus Express and Mars Express are providing the crucial evidence that will aid understanding of the dramatic and subtle events that set these seemingly similar planets on very different paths of evolution. I'm Rebecca Barnes. Thank you for watching the Science at ESA Vodcast.